Hello everyone, welcome to the channel Data Science with Harshit. So this is the long awaited series on machine learning. So I have been working on this project so that basically I could tell you how to work on a machine learning project from end to end. So this particular series would cover all the steps that are basically carried out in any machine learning project, going from collection of data up until deploying your machine learning model into production. Now, if you haven't seen my other video, which is on how to optimize or how to create an effective data science portfolio, so there I have mentioned basically what kind of projects you should be actually working on in order to make your portfolio stand out. So yeah, so this particular series is basically intended to give you an idea of what an end-to-end machine learning project looks like. And I would be basically using another blog of mine that I've written on task cheat sheet to solve any machine learning project. So all of those links are basically provided in the description, so keep them handy in order to follow me along in this series. So I've broken it down into 4 videos, this particular series of end-to-end project. So we will be working on a supervised machine learning regression problem. Now what I require from you is the prerequisites. Basically you should have some basic understanding of Python, NumPy, working with external libraries, and some basic understanding of machine learning. But if you do not, I have provided a link to the book that you can read first few chapters, so that you get a good refresher on what actually machine learning is, what kind of problems do we solve. And we have picked up one particular problem to solve, and basically right after completing this series, you can go ahead and develop more complex solutions and work on more complex problems. So all of the resources basically are provided in the description. We would be going from data collection to initial exploration, exploratory data analysis, creating pipeline of transformation of data, and then we are going to dive into model engineering, how to select and train a model. Then we're going to fine tune the parameters, hyperparameter tuning, and then the last step, basically after finalizing our model, we would also deploy that learned model on Heroku using a Flask web service. So this is like an end-to-end project that we are going to work on. So let's dive right into it. We are going to solve a regression problem, and the data that we have taken for this is from the UCI machine learning repository. Again, the link you can find in the description. So without any further ado, let's get started. So for the first 3 videos, we are going to be using Jupyter Notebook. So I have again given the link to this notebook and the entire repository in the description. So first we have basically this notebook. I have jotted down a few points that we are going to cover in this series. So we're going to see how we are going to collect the data, which is the data set that we have chosen for this particular problem is basically auto MPG dataset from UCI machine learning repository. So this is basically the link for the page for this particular dataset. So they've given some attribute information here that we can make use of in order to frame our problem, which is basically the second step right after we download the data. So this is the page. Again, the link to this is given in the description. This is, you can see that this is a task, is associated task is a regression. This is a multivariate data set. We have 398 instances. That means 398 rows in this particular data set. It's a fairly small data set, but it's good for learning purposes. You can, again, as I mentioned, you can go ahead and pick a more complex data set if you want to follow along and also work on something different. So Yeah, so from there, the second step, basically you can say we are going to define the problem statement. So this particular video would cover data collection, data problem statement, that is defining problem statement, sorry, and then we're going to dive into EDA, which is exploratory data analysis, to figure out which features are actually important. So also make sure that if you would be working on a fresh data set, there would be this. So I have like condensed all of this information in these 4 videos, but it would take a bit more longer for you to work on a different data set. So yeah, feel free to spend some time with the data set, connect with it, and then start preparing the data and transforming it once you have figured out what actually is worth looking into, what are the important features, and if you can develop some new features out of the existing ones, which we are going to see just now. So starting off with, first thing that we need to do is we need to collect the data from the link that we have. So this again is the archive data. This is the link to the dataset that we have. And what I am doing here is I am simply using the wget command, which is this exclamation you can see. This basically means that I am trying to run a shell command through my Jupyter notebook. So what I'm doing is I'm downloading the data from in this particular cell. So once you run it, it will create a new file for you in your directory. So let's try to run this. So I already have the file downloaded. So it has created another file, which is basically an added suffix .1 ahead of it. So I have like 2 files right now. So if I could show you. So you see that I have this particular file which has just been downloaded. So our data has been downloaded, and now we are going to look into what actually our data basically looks like. So from this data file, so the format is in data. So we're going to see how we can read this file into a data frame. Now the next thing that we do is we import a few general use case libraries. So I have imported NumPy, then I have imported pandas, which we are going to use to manipulate our data, and matplotlib to plot a few charts, few graphs that would be helpful in order to understand those features. Seaborn again to plot a few charts and pair plots that we're going to see just in a bit. So the next thing that we are doing here is we are trying to read the data frame, the file which is in .data format. So the first thing that I've done is I have defined the columns, as you can see. So we have, if you look at the data here on the machine learning repository website, so we have these attribute information: mpg, cylinder, displacement, horsepower, weight, acceleration, so on and so forth. So I have defined the columns in the first line, that these are the columns that I am interested in. Then I am going to use the read CSV function for reading our .data file. So I have provided the path here. Then I have mentioned the names of the columns. So this, I have provided the list that I have just defined as the names. Then NA values is basically telling you which columns or which values to be identified as NaN. So I have passed question mark there. Then comment is \t, which is basically telling you like after encountering the first \t, the rest of the line basically remains, would be ignored by this function. Then separator or the delimiter is basically a space. Then I want to skip all the initial spaces, so that is equal to true. So once I run this function would return a data frame. So I've captured it in df variable. So The first thing that I do is I make a copy of it. So I've copied the data set, basically the data frame, into this data variable. So let's try to look at, so if we run, let's try to run this, and the second cell, then I run this data.sample20. So basically this sample function gives you a sample of 20 rows, extracting a few random 20 rows from the from our data frame. So this is what we have in our data. So as we talked about, we have mpg, cylinders, displacement, height, weight, acceleration, model year, and origin. Origin, you can see that we have 1, 3, 2, 1. So these are a few. I think this might be a categorical column. So since we have only a few values that are repeating, so, and we have cylinders as 4, 8, 6. Again, this would again be a categorical column. Then we have mpg here. We have displacement, which is in the range of 140, 400. It is varying for different vehicles. We have model year, which is 80, 74. So basically this is like 70s and 80s vehicles data. So that is your year, 80, 74. And acceleration, we have weight of the vehicle, and then we have horsepower as well. So great. So if we look at the data description, basically the data concerns city cycle fuel consumption in miles per gallon. So we see that this is miles per gallon. So as we can see, mpg. So this is the variable that we are interested in predicting. So this basically helps us in defining our problem statement. So our problem statement is around this particular column, and this would be our target variable. The rest of the features, these features would be treated as our feature variables. So the problem statement basically that we have defined is the data contains mpg variable, which is continuous data, and tells us about the efficiency of fuel consumption of a vehicle in 70s and 80s. So our aim here is to predict the mpg value for a vehicle, given we have all the other attribute information of that particular vehicle. So the next thing that we do is step 3, which is exploratory data analysis. Now here I have 6 steps which I believe should be carried out, at least for this particular data set. There might be a few different steps that you would have to perform in order to explore a different data set, which might be a little more complex data set. So accordingly you can add steps. So I have the first step, which is check for data types of columns. So you'll have to first figure out which all columns are numerical, which all are quantitative basically, and which are qualitative. So numerical or categorical, you have to figure that out. So you can do that by checking the info of the data frame. That also gives you every information regarding your column data type and the number of rows that have non-null values. So you see that we have range index. Basically we have 398 entries going from 0 to 397, and we have these particular columns: mpg, cylinders, displacement, horsepower, as we discussed. All of those have 398 rows, except for the horsepower column, which is basically having 392 rows only. So there's 6 rows that are missing, that have null values basically. And cylinders have integer data type, and so does we have origin and model year, which also have integer variables, integer data type, and rest of them are floating point numbers. So that is good. We have all of them as numerical as of now, but we saw that origin and the cylinders are categorical, since they contain a category of a class of variables, values, sorry. So I don't think we have anything related to formatting here. So formatting looks good. We have all of them as numerical columns. For other data set, you might have some object data type that you would have to clean out first if required, and then accordingly you will process them. Now we'll check for this again the null values that are there in the horsepower column. So we'll run this. So data.isNull basically tells you how many if the particular row is null or not. It will give you true and false, and I have the sum cascaded ahead of it, which basically calculates the sum of all the true values that are generated by the isNull method. So if I run data.isNull, so it will give you false, true based on whether that particular row or that cell has a null value or not. And if I add sum, so that basically gives me the sum of all the true values. So for the horsepower column only, I have 6 missing values. So we'll see, we can either drop these rows or we can impute some values. We can fill these empty values based on the characteristic of that particular column. So let's look at a few summary statistics of all these quantitative variables. So I have so basically describe method of the particular data frame gives you all that information. So count is basically the number of rows. So we have 398, horsepower has 392 and rest of them has 398. This gives us the mean value of each of those columns. Standard deviation gives us the standard deviation, minimum value, the lowest value of each column, then 25th percentile value, 50th percentile value, 75th, and then the maximum value of each column. So this gives us a basic idea of what where the values lie, what are the mean, and all of those things. So this is again a very important method to get a good basic understanding of what the data actually looks like and where the values lie. Now, to address the issue of the horsepower missing values, let's look at the box plot to get a good understanding of how many outliers are there. So we have just a few. So it's general that average or the mean value of a particular column is more sensitive to outliers. So instead of so if a data set contains a lot of outlier values, so it's better to use median to fill those null values rather than using mean. So there are a bunch of ways that you can fill or impute those missing values, but here since we have just a few outliers, so I've picked up median to be imputing value. So we'll be imputing those missing values with the median of horsepower column. So all you need to do is you first need to calculate the median. So here I have the median function which I have invoked over the horsepower column, and then I have this horsepower dot fill na. So that is fill na method. Basically what it gives you is it fills all the na values with the value that you have specified. So if you have specified 0, it will fill 0 instead of all the in place of all the NaN values. So I have mentioned the median. So I first calculate the median of the horsepower column, and then I have filled those missing values with the median. So once we do that, now if we look at data.info again, so you see that we have 398 rows in all the columns. So basically all of the values, all the missing values have been filled with the median. Great. Now let's look at the category distribution. So the category distribution again, we are going to see that the cylinders basically are 4, 8, 6. So we want to see how what are the unique values. So basically how many rows belong to a particular class of value. So if we first let's do value counts. So we have 4, 8, 6, 3 and 5. So these are basically the classes. Now the number of vehicles which have 4 cylinders, that are 204. Number of vehicles that have 8 cylinders, that is 103. Number of vehicles that have 6 cylinders, 84, so on and so forth. Now what we do by dividing by the length, basically the total number of rows,
is we try to look at the distribution of how many values are basically combined or allocated to a particular class of value. So you can see that more than 50% of the values or the vehicles belong to this four cylinders, and then 25% of the vehicles have 8 cylinders, so on and so forth. So this is basically the category distribution, which gives us an idea that how our testing data should be. So basically it helps you figure out that, yeah, so if we have the total data, we are getting more values of four-cylinder vehicles. So that's something that you'll have to keep in mind while you're training your model. So we'll see how we can simply address that using a scikit-learn function. Again, doing this for the origin categorical variable as well. So we have simply three class values here, 1, 3, and 2. So we have three origins, 1, 2, and 3. So one has a lot of values, a lot of rows that are allocated to it. So we have 249 vehicles which have origin 1, 79 vehicles which have origin 3, 70 vehicles which have origin 2. So we'll see how the 132 is basically values that have been assigned instead of country names. So we have given origin as country, so one is basically we have segregated as India. So we'll see how we can address that. I've added a slight complication to the dataset myself so that we are addressing the categorical column issue as well. Now, to look at the last step is in the exploratory data analysis. If you see the points that I have, so I have imported the Seaborn library. So I'm using the Seaborn library to get the pair plot of all the variables so that we can look at the correlation of all the variables with each other. So this will take a few seconds. So here we have our pair plots. So you can see that we have every variable is plotted against every other variable. So let's say we have mpg over here, which is our target variable, and then we have displacement, weight, horsepower, cylinders here. So displacement, you can see that displacement, this is the third column, is the displacement column. So mpg is negatively correlated, kind of negatively correlated with the displacement. So is with the weight, and so is with horsepower as well. So it is negatively correlated with the displacement, horsepower, and weight. We can see that displacement is positively correlated with weight, it's positively correlated with horsepower. So that's what pair plot gives you a good understanding of the relationship between each variable with every other variable, and this will help us figure out what are the more important columns that we should look at. So that was about the exploratory analysis. The next important step is to divide the data set into training and testing so that we keep it unbiased, because our mind is biased towards looking at the data and then picking up a model which is suited for the data. So we don't want to do that. The first thing, right after you get the data, the first things that you should do, just split the data into training and testing, and then you do all the transformation, all the cleaning and wrangling that is required.
So that was all about the first part of the project, which included downloading the data, defining the problem statement, initial exploration, performing exploratory data analysis, figuring out which features are important, checking the correlation, splitting the data into training and test, and then creating a unbiased and balanced split using stratified shuffle split function from the scikit-learn model selection module. Now in the next video, we are going to cover data preparation, how to create pipeline and automate all of these steps that we have learned so far, so that we can get our data ready to be input into the machine learning models. So stay tuned for the next video.